Good day everyone. Good day sir. I'm Ryan TRAJADA. We are the group 6 where we are discussing about the nuclear power plant. So, nuclear power plant history. Did you know that Bataan Nuclear Power Plant is a nuclear power plant completed but never fueled on Bataan Peninsula, 100 kilometers west of Manila in the Philippines? It is located on a 3.57 square kilometer government reservation at Napot Point, Morong, Bataan. Construction on the Bataan Nuclear Power Plant began in 1976, followed the 1979 3 Mile Island accident in the United States. Construction on the BNPP or the Bataan Nuclear Power Plant was stopped, and the subsequent safety inquiry into the plant revealed over 4,000 defects. Among the issues raised was that it was built near major earthquake fault lines and close to the dormant Mount Pinatubo. By 1984, when the BNPP was nearly complete, its cost had reached $2.3 billion equipped with a Westinghouse light water reactor. It was designed to produce 621 megawatts of electricity. So, dito sa Pilipinas, meron tayong tinatawag na BNPP or the Bataan Nuclear Power Plant na ipinatayo noon sa panahon ni Marcos. Ang BNPP sana ang pwedeng makatulong sa lalo na sa pagkonsumo ng paggamit ng kuryente. So, ito ay naipatayo noon sa panahon ni Marcos, ngunit hindi ito nabuksan dahil nakitaan ito ng napakaraming depekto na umabot sa 4,000 defects. So, ito rin ay may masamang maidudulot lalo na sa kalusugan ng tao. So, ito rin yung mga naging dahilan kung bakit hindi ito tuluyang nagamit o nabuksan. A nuclear power plant is electricity was generated by a nuclear reactor for the first time on September 3, 1948 at the X-10 graphite reactor in Oak Ridge, Tennessee in the United States. It was the first nuclear power plant to power a light bulb. The second more giant experiment occurred on December 20, 1951 at the EBRI Experimental Station near Arco, Idaho in the United States. On June 27, 1954, the world's first nuclear power plant to generate electricity for a power grid started operations at the Soviet city of Obninsk, the world's first full-scale power station in Calder Hall in England. Opened on October 17, 1956, the first full-scale power station with a PWR-type reactor was a shipping port atomic power station commissioned on May 26, 1958. A brief history of nuclear power. In 1951, the world's first experimental nuclear reactor produces electricity in Idaho, USA. In 1953, U.S. President Eisenhower proposes Atoms for Peace programs, which shifts research efforts towards power and electricity generation. In 1954, world's first commercial-scale nuclear power stations starts up in Obninsk, USSR. In 1954, U.S. launched first nuclear-powered submarine. In 1956, first British reactors starts up. In 1957, first large commercial reactor built in U.S. in Shippington, Pennsylvania. In 1959, France starts up first commercial reactor. In 1960, Westinghouse designed commercial pressurized water reactor or PWR starts up. General Electric design commercial boiling water reactor or BWR starts up. In 1962, Canada's Canada-Deuterium Uranium or CANDU reactor starts up. In 1964, Soviet Union's built first two commercial power plants. In 1965, DBI starts developing the DBI thorium reactor. In 1972, world's first commercial fast breeder reactor or FBR starts up in Kazakhstan. In 1970s until early 2000s, share of world's electricity coming from nuclear remains stable at 17% range. In late 1990s, third generation reactors developed. In 2009, DBI ready to build first reactor, and the present increased the interest in nuclear power. So, Enrico Fermi in 1942, Fermi successfully created the first man-made nuclear chain reaction in a squash court under the stadium at the University of Chicago. The Manhattan Project kicked into full gear. Two types of bombs were pursued simultaneously, one made with enriched uranium and the other made with plutonium. Giant secret cities were built very quickly. The one in Oak Ridge, TN, had a reactor that created the first gram quantities of plutonium for study, but its main task was to enrich uranium. So the first nuclear power plant in the world launched on June 27, 1954 in Obninsk village of Kaluga region at the A.I. Liponsky Physics and Energy Institute Laboratory B. Was launched the first nuclear power plant in the world, equipped with one uranium and graphitic channel reactor with water heat carrier of 5 MW AM1. This date marked the beginning of the nuclear energetics history. During the World War II in the Soviet Union started to create the nuclear arms. The work on it was led by scholar, physician, academician Kurchatov. In 1943, he founded a research center in Moscow, Laboratory N2, which later was reorganized into the Nuclear Energy Institute. In 1948, a plutonium factory with a few industry reactors was built. In August of 1949, the first Soviet nuclear bomb was tested, when beneficiated uranium production was organized and developed on industrial scale. The discussion of problems and lines of energetic nuclear reactors, creation for further applications in transport and electric energy, and heat extraction began. On Kurchatov's instruction, the Russian physician E.L. Feinberg and N.A. Dolgel started to develop the design of nuclear power plant reactor. So, besides energy generation, the Obninsk nuclear power plant reactor also served a base for test researches and isotopes generation for the needs of medicine. The experience of operation of the first experimental nuclear power plant proved entirely the correctness of engineering decisions made by the expert of nuclear sector, enabling to start a large-scale program of construction of new nuclear power plants in the Soviet Union. In May of 1954, the reactor was launched, and in June of the same year, Obninsk Nuclear Power produced its first industry current opening, the way of applying the nuclear energy for peace goals. Obninsk Nuclear Power Plant had successfully operated for almost 48 years. On April 29, 2002, at 11:31 a.m. Moscow time, the reactor of the first nuclear power plant in the world in Obninsk was stopped. According to the RF Ministry of Nuclear Energy Press Service, the plant was stopped for economical reasons, exclusively due to the fact that this high maintenance insecure condition became more and more expensive each year. So, on the basis of the Obninsk nuclear power plant was created the Nuclear Energetics Museum.
In ORTAL, and I'm going to tackle about nuclear power plant equipment. In nuclear power plant, we need to familiarize two main sections. We have the reactor building, which contains the reactor core, the reactor vessel, the torus, the recirculation pumps, and many more. And the other section is the turbine building, which consists of turbines, generators, condenser, and many more are in this building. And also to mention na rin, we have the outside operation, which passes the electricity to switchyard, and the water or process steam used to the cooling towers. Now, let me discuss the main equipment in nuclear power plants. First, we have the nuclear reactor. In power plants, a nuclear reactor is an essential component like a heat source that includes fuel and its reaction in the nuclear chain, including nuclear and waste products. To start, you need a uranium ore. Once you've got a row of uranium ore, you need to process it into uranium-235 or uranium-238. So you do this in a centrifuge process. Before you can burn it into a nuclear reactor, you need to create uranium fuel cells. So once you've got the fuel, you need to burn it in a nuclear reactor. This is the first step towards turning it into a usable energy. So, nuclear reactors produce heat by fission. This heat is used to make steam, and steam turbines runs generators to produce electric power. So, there are different kinds of reactors used in nuclear power plant. These are the pressurized water reactor, boiling water reactor, and fast breeder reactor. Next, we have the heat exchanger. Water from a pressurized vessel is pumped into a heat exchanger, or also known as a steam generator. So the thermal energy of water from a pressurized vessel is transferred to water from a river or from a cooling tower via heat exchanger and converted to high pressure steam as we use water in a pressurized vessel to create steam. The heat exchanger takes heat and uses it to convert water into steam. So it works much like a boiler, but instead of using fuel, you need to connect it into a heat source. So the heat input is marked by a flame when you're placing it. And heat exchanger also require water input in precisely the way boilers do. So they can heat up to 103.09 units per second of water into 500 degrees Celsius steam. And heat exchangers produce nothing when they are below 500 degrees Celsius. Since they only cool as a consequence of heating water, they will never cool to below the temperature once they've reached it. So, heat exchangers transfer 10 megawatts of power. So, you need 4 exchangers to fully consume the power produced by a lone reactor. Now, the steam can be transported to the steam turbine using a normal pipes. Moving on, we have the feed water pumps. The water level in the steam generator and the nuclear reactor is controlled using the feed water system. So the feed water pump has the task of taking the water from the condensate system, increasing the pressure and forcing it into either the steam generators or directly into the reactor vessel. So the system of feed water pumps usually contains 3 parallel lines of feed water pumps with common suction and discharge headers. Next, we have the steam generation. So, steam generators are heat exchangers used to convert water into steam from heat produced in a nuclear reactor core. They are used in pressurized water reactors or the PWR between the primary and secondary coolant loops. So, in all power plants, steam production is normal. However, the method of generating will change. Most power plants use a water reactor using two ends of water to generate steam. So the primary loop carries very hot water to heat exchange, Once the water is circulated at low pressure, it then heats the water to generate steam to transmit to the turbine section. Next, we have the nuclear turbine, or also known as the steam turbine. The purpose of this steam turbine is to convert the heat contained in steam into mechanical energy. So the engine housed with the steam turbine is usually structurally separated from the main reactor building. It is so aligned to prevent debris from the destruction of a turbine in operation from flying towards the reactor. Nuclear reactors are used at nuclear power plants for electricity generation and in nuclear marine propulsion. Heat from nuclear fission is passed to a working fluid, which it turns or runs through steam turbines. These either drive ship's propellers or turn electrical generator shafts. So we have the generator. So this converts the rotational speed of the turbine generator coupling into a electrical energy. So this electrical energy is then transported to a higher voltage through the transformer and then transmitted through transmission lines to the nearest power grids. Second to the last main equipment of nuclear power plant, we have the cooling system. So a cooling system removes heat from the reactor core and transports it to another area of the plant, where the thermal energy can be harnessed to produce electricity. And typically, the hot coolant is used as a heat source for a boiler, and the pressurized steam from the boiler powers one or more than turbine driven electrical generators. So before I proceed to the last main equipment of the nuclear power plant, let me discuss to you some components of cooling system. So first we have the cooling water. So water taken from the river, reservoir, or the sea and used to liquefy the water vapor in the condensator. So it can be directly returned to its origin or be reused via cooling tower. Next, we have the cooling tower. So it is a device that makes it possible to yield to the atmosphere, which acts as a cold focus. So it is part of the residual heat produced during the electrical generation. So it is used to cool the water that circulates inside the condensator and is part of the plant's auxiliary cooling circuit. And next, we have the condensator that heat commuter composed by a set of tubes where cooling water circulates. So the water vapor going inside the condensator from the turbine is liquefied. So this conversion rather produces a vacuum that improves the turbine's performance. Lastly, we have the emergency power supply. Um, Nuclear power plants need reliable emergency backup power in order to maintain a safe condition after external power failure and to meet related regulations. The capacity and endurance of backup systems should be able to be calculated by accurate modeling of the electrical, mechanical, and service uses of energy. So the major questions will be how long will backup energy supply be required in the worst event scenario. So the emergency power supplies of a nuclear power plant are built up by several layers of redundancies such as diesel generators, gas turbines, generators, and battery buffers. So if necessary, the emergency power supply allows the safe shutdown of the nuclear reactor. So less important auxiliary of pipelines are not supplied by these backups. So most of the required power is used to supply the feed pumps in order to cool the reactor and remove the decay heat after a shutdown. And that's all for nuclear power plant equipment. Thank you.
Previously, the last reporter already discussed the equipment and component used in nuclear power plant. Now, let's discuss how does nuclear power plant actually works, especially that the issue of reviving the Bataan nuclear power plant resurfaced. My name is Fernando F. de la Rosa, and we'll discuss how does nuclear power plant work. For starters, let's define nuclear power plant. A nuclear power plant is an industrial site that generates electricity from nuclear power. It releases in the form of thermal energy through nuclear fusion chain reaction. Inside the vessel of nuclear reactor. So, ito po yung pictures na ito po yung picture ng nuclear reactor natin, itong bilog. Then, may fuel pong binabala. So, the special feature of nuclear power plant is it contains the nuclear fuel. So, ito po yung nuclear fuel natin, which is yung uranium. And has a system that make it possible to start, sustain, and stop the nuclear reaction in controlled manner. The way nuclear power plant works is similar to a conventional thermal plant, where thermal energy is obtained through the combustion of fossil fuels. However, in nuclear power plant, the energy is obtained via nuclear fusion chain reaction of the uranium atom. So, yung uranium atom natin ay yung nuclear fuel natin. So, basically, the conventional thermal plant is obtained via combustion of fossil fuels. So, sa thermal plant is sinusunog nila yung fossil fuels to generate electricity. On the other hand, sa nuclear power plant naman, energy is obtained through the nuclear fission chain reaction of the uranium atom. So, dito, sinusunog yung uranium atom natin to generate electricity. All nuclear power plant use nuclear fusion, and most nuclear power plant use uranium atoms as their fuels. Pero bago yan, ano bang nangyayari sa loob ng nuclear reactor? Sa nuclear reactor, nagkakaroon ng tinatawag na nuclear fusion, where atoms are split apart which releases energy. So, ito po yung illustration ng nuclear fusion natin. A neutron collides with the uranium atom and split it. So, nag-split sila, nagkahati. Then, once na naghiwalay sila, it produces energy, and in the form of heat and radiation. The split uranium atom, matatamaan ulit ng another neutron, which repeats the process of generating energy. This is what we call nuclear fusion chain reaction. And pag once na paulit-ulit na nangyayari, it produces large amount of energy. So, next, there are different types of nuclear reactor. Yung nuclear power plant natin, makaklasify siya depende sa nuclear reactor na ginamit nila. But the two outstanding designs are present in over 80% of the almost 450 operative units in the world. So, this is the most common type of nuclear reactors. First is pressurized water reactor, or PWR, and boiling water reactor for the second one. Pressurized water reactor is a type of light water nuclear reactor. Paano ba gumagana yung pressurized water reactor? So, yung pressurized water reactor natin, may tatlong water system siya. Yung first water system, ito. Second water system, and third water system. Sa first water system, nandito yung high pressure and heat water natin. So, sa reactor vessel natin, iniinit or nagsusunog tayo ng uranium para mapainit yung tubig natin. Then yung high pressure, may loop na dadaan dun sa second water system natin, which is yung sa may steam generator. Ayun yung magpo-produce ng steam papuntang turbine. Then yung steam, ayun yung magdadrive ng turbine para umikot yung generator natin to produce electricity. Then, yung used steam natin, which is, ito nga, yung steam, mapupunta naman siya sa condenser, which is, makocondense yung gas to liquid. Kumbaga, ibabak niya yung form niya as liquid. So, yung process na ito is paulit-ulit na nangyayari. Tandaan, yung pressurized water reactor, hindi nagko-combine yung first water system natin tapos yung second water system. Kumbaga closed loop sila. Comparing sa boiling water reactor, which is yung next na reactor natin. Sa boiling water reactor naman, ito yung pagkakaiba nila. Wala siyang steam generator comparing sa pressurized water reactor natin. So, sa BWR, heat water and produce steam directly inside the reactor vessel. So, ito yung reactor vessel natin. Yun nga, nagsusunog tayo yung uranium atoms to produce energy, which is yung energy matatransfer sa water natin. Kumbaga, iinit siya, then makapag-generate tayo ng steam connected sa turbine natin. Yung steam na yun mag-iikot sa turbine natin. Kumbaga, ayun yung prime mover niya to rotate the generator natin and produce electricity. Then yung once na nagamit na yung steam, mapupunta naman siya sa condenser. Kumbaga, from gas, i-convert siya sa liquid, which is ay tinatawag na condensation process. Then, yung condensed water, mapupunta ulit sa reactor vessel natin. Kumbaga, paulit-ulit lang siyang nangyayari. Comparing sa PWR, ito, directly, ginagamit yung tubig. While sa PWR, yung may device pa silang ginagamit, which is ayun yung steam generator to produce steam. Next slide. For the summary on how nuclear power plant operates, the way nuclear power plant works can be simplified into 5 stages. First is the uranium atom fission takes place inside the nuclear reactor. It releases a large amount of energy that heats the coolant, water circulating at very high pressure. This water is transported by a primer circuit to heat exchangers, which is a steam generator sa PWR. Pagdating naman sa BWR, wala siyang steam generator. Kumbaga directly na nakapag-produce na kagad ng steam. Then yung steam is transported to a generator turbine set via secondary circuit. May tubo na dadaanan yung steam natin papuntang generator turbine. Once nandun na yung turbine, ito yung third step. Once nandun na yung steam, yung vanes dun sa turbine is mag-move, which is it tends na mag-rotate. Then yung alternator and the mechanic energy is transformed into electricity. When the water steam goes through the turbine, it sends it to the condenser to cool off and become liquid water again. So, ayun nga, yung mga nagamit ng steam na nanggaling sa turbine natin, kumbaga yung mga used steam na, is ibabalik ulit siya in form of liquid, kumbaga condensation process na siya. Then, the water is transported to the new steam generator to be back again inside the closed circuit. Kumbaga, paulit-ulit na nangyayari. Babalik yung tubig papunta dun sa reactor vessel natin, if BWR. Pag sa PWR, closed circuit sila. Hindi directly na humahalo yung tubig na nandun sa kada water system. Kumbaga, natatransfer lang yung heat na nanggagaling sa reactor vessel natin sa another liquid, which is, ayun nga, sa ibang form ng tubig na which is yung sa water system natin, yung kumbaga, sa first water system natin, hindi manahalo yung tubig doon. Matatransfer lang yung heat ng first water system sa second water system, which tends to produce steam. And ayun nga, mapupunta yung steam papuntang turbine, then babalik yung steam into liquid form. Ganun lang yung paulit-ulit na nangyayari yung process. Then, that's it. I hope you learned something about nuclear power plant and how it works. Thank you.
Hi, good day to everyone. My name is MARVIN, and I'm going to present to you the nuclear power plant economics. Let's get started. So let's talk about nuclear power plant economics. For starters, we're going to tackle what is the price of a nuclear power plant for its year of return, and the time needed to construct a nuclear power plant, and what is the price for its kilowatt per hour. the state of nuclear energy today around the world is 440 nuclear reactors that is currently providing 10% of the global electricity. And in the US only, the nuclear power plants have generated almost 20% of electricity in the last 20 years. So most nuclear power plants were designed to be operating for 25 to 40 years, with an average age of 35 years. A quarter of them was built in developed countries that will mostly shut down by 2025. And after the Fukushima meltdown, a number of countries have begun to consider phasing their own nuclear programs, with Germany expecting to shut down their entire nuclear fleet by 2022. The US has a 95 nuclear reactors in operation, but only one new reactor has started up in the last 20 years. Over 100 new nuclear reactors are being planned in other countries, and 300 more are proposed, with China, India, and Russia leading the way. So let's tackle on to the first topic. So the price of a plant. So we're going to give the first example here in the Philippines, where the construction of the Bataan nuclear power plant began in 1976, which by 1984, when the Bataan nuclear power plant was nearly completed, and it cost almost $2 billion, and it was designed to produce 621 megawatts of electricity. Can you imagine that if that reactor has been gone online and today, it would nearly produce 621 megawatts of energy in today's market? And in today's world, when constructing new nuclear reactors, it will cost over $7 billion, which makes them very expensive to proposition. Some of the newer nuclear projects have gone over schedule and over budget. Next is we're going to talk about the year of return. So according to the Nuclear Energy Institute, the nuclear energy industry plays an important role in the job creation and the economic growth, providing both near-term and lasting employment and economic benefits, which the 100 reactors in the United States most generate substantial domestic economic value in electricity sales, which revenues with the estimate of 40 to 50 billion each year, with more than 100,000 workers contributing to the production. So let's give an example for the year of return. As you can see, I have simulated a graph where, as you can see on the top left part, the construction time. So let's say the project took 8 years to complete, which is a pretty long time. So I'm putting into consideration if the plant was here in the Philippines and it was the Bataan nuclear power plant. So it took them 8 years to complete. So the construction cost was equals to, as you can see, it was almost $2 billion. And in today's time, the electricity price was per megawatt hour is 160. If you estimate that and reduce it with the subsidies and taxes, it will go down to 122 euros per megawatt hour. And if you convert that to Philippine pesos, is roughly 7,000 pesos. So with the help of the government, and the price may be lowered through subsidies. So next is as you can see, as at the start, due to the high price of starting a nuclear reactor, which the cost of starting it is fairly large compared to other energy resources. But as you can see, the return is stably climbing throughout the years compared to other energy sources. So that is the one thing that people are considering when they go into the nuclear energy business. So when considering how long is the plant going to be built, so nuclear power plants are more complex and other large-scale power generation plants. So the more capital intensive and it may take longer to construct. Typically, a nuclear power plant will take over 5 years to construct. Oh, so for example, here in the Philippines, the construction in the Bataan nuclear power plant began in 1976 and finished in 1984, which took them approximately 8 years to finish. And the budget was $2.3 billion. Another example was today and the Vogel nuclear power plant, which is constructing its Unit 3 and Unit 4, which the Unit 3 started in March 2012, 2013, and to be finished in the second quarter of 2022. And the Unit 4 began in November 19, 2013, and will likely to be finished in 2023. So, additional information about this power plant, because the two units have suffered several delays and cost overruns. So, the certified construction and capital cost of the two units were originally 14 billion, and by 2021 they were estimated to be over 28 billion dollars upon their completion in 2023, which is suggesting that the price of these power plants are not concrete to be said, because people are still always considering the design and safety of these power plants, which tends to prolong the completion and go over the budget. Another example is the Barak nuclear power plant, which is located in the UAE, which started in July 19, 2012, which the Unit 1 is completed on December 2018. It has entered commercial service in 2021. So we're going to talk about the price of its kilowatt per hour. So in the US, in 2019, they have revised the levelized cost of electricity from the new advanced nuclear power plants that is going online in 2023, which is the Vogel power plant, the Unit 2 and 3, which are estimated to produce, which is expected to hold a capacity of 1,117 megawatts. So their estimated price range should be 0.775 kilowatt per hour before the government subsidies. Using the regulated industry 4.3 cost of capital and for over a 30-year recovery period. Another firm, the financial firm Lazard, also updated its levelized cost of electricity reporting, which is costing them between 0.118 kilowatt per hour and between 0.192 kilowatt per hour using the commercial 7.7% cost per capita. Here is the example of the electricity production cost of a nuclear power plant in the United States between 2002 to 2019. As you can see, the prices vary. It's stated by megawatt per hour. So per megawatt, in 2002, they started at $30 and $30 which led to as you can see, there was a sudden spike in the between which started in 2008 roughly and began to peak at 2012 because all due to energy crisis uh in the world market. So prices of gas uh were soaring, and thus nuclear power plants were trying to compensate them. You, so there was a increase in supply the energy production. But due to the introduction of other renewable energy sources, the prices have calmed down and begin to stabilize back to its original starting point. So, in conclusion, a new nuclear power plant is very difficult undertaking to finance. The economic modeling is complicated by the problem of a very high capital cost during the construction phase, extensive planning periods with high-risk capital, and many political influences over a long decision and planning process. Nonetheless, for the decision makers, the NPV and the IRR, which derive by discounting the predicted future cash flow and are critical figures, and these figures, however, are very dependent on the scenarios and input data utilized in the calculations. As a result, the proposed tools allow the decision makers to simulate the economics of a new construction project under a variety of uncertain boundaries conditions, allowing them to identify and quantify the risk. That is all for the nuclear power plant economics. Thank you.
Good day everyone, I am DARYL BURLA and I will be discussing the last topic for this presentation. It is all about the advantages and disadvantages of nuclear power plants. So nuclear energy comes with many benefits and drawbacks, which is what makes it as a controversial alternative energy source. Here are the main nuclear energy pros and cons. First, we have the zero carbon emission. Second, the reliable power sources. Third, we have the low-cost energy. Fourth is promising future energy supply. Five is high energy density. Six, we have the stable base load energy. Seven is produces low pollution. And lastly, we have the sufficient fuel availability. So to better understand the advantages of nuclear power plants, let me explain it further. So we have here the first advantages of nuclear power plants. The zero carbon emissions. So why zero carbon emissions? Nuclear power reactor do not produce any carbon emissions. This is a huge advantage over the traditional sources of energy. In fact, according to the Nuclear Energy Institute, the United States avoided more than 476 million metric tons of carbon dioxide emission in 2019. That's the equivalent of removing 100 million cars from the road and more than all over the clean energy sources combined. So it is also keep the air clean by removing thousands of tons of harmful air pollutants each year that contributes the acid rain, smog, lung cancer, and cardiovascular diseases. So despite producing a massive amount of carbon-free power, nuclear energy produces more electricity on a less land than any other clean air sources. A typical 1,000 megawatt nuclear facilities in the United States needs a little more than 1 square mile to operate. NEI says that the wind farm requires 360 times more land to produce the same amount of electricity. And solar photovoltaic plants require 75 times more space. To put that in perspective, you would need more than 3 million solar panels to produce the same amount of power as a typical commercial reactor, or more than 433 wind turbines, the capacity factor not included. So next is we have here the second advantages of nuclear power plant, which is the reliable power source. So while some energy sources are dependent upon weather conditions, like solar and wind power, nuclear energy has no such constraint. It doesn't matter if the wind isn't blowing or if the day is cloudy. Nuclear power plants are also reliable because we have enough uranium on the planet to generate energy for the next 70 to 80 years. Well, that may not sound like a long time, it is longer than many fossil fuel are estimated to last. And there are other nuclear energy sources being explored to power nuclear power plants. As you can see here, nuclear energy has by far the highest capacity factor of any other energy sources. This basically means that the nuclear power plants are producing maximum power more than 93% of the time of the year. So the third one is low-cost energy. The cost to produce electricity from nuclear energy is much lower than the cost to produce energy from gas, coal, or oil unless those resources are located near the power plants they supply. Also, nuclear power plants doesn't experience the same kind of price fluctuation that traditional fossil fuel energy sources like coal and natural gas do. Because of that, the price of nuclear energy can be predicted well into the future. Nuclear energy also has the added benefit of facing comparatively low risk for cost inflation, unlike traditional fossil fuels that regularly fluctuate in price. So the fourth advantage of nuclear power plant is promising future energy supply. So we all know that nuclear fusion is the holy grail of harnessing the energy. If we can learn to control the atomic fusion, the same reaction as those fuel the sun, we could practically have the unlimited energy. At the moment, this method has some serious challenges that need to be worked out. If we are start using them on a large scale, however, the potential it has an important to keep in mind when thinking about energy generation is in the future. So next is produces low pollution. Nuclear energy has one of the lowest environmental impact of the all energy sources. Comparable with the total impact of wind and solar, it doesn't emit air pollution. Its safety keeps its waste out of the environment, and it requires a very small amount of land. The current consumption of the nuclear energy already reduced over 555 million metric tons of emission every year. This reduce in greenhouse gases is the great indicator of how switching to nuclear energy can help reduce our effect on global climate change in our long run. So the sixth advantage, we have here the sufficient fuel availability. Like fossil fuels, the uranium used to supply nuclear power plants is in the limited supplies. There are more fossil fuel discoveries we have yet to make, but they are fewer than farther between than ever, and will eventually run out. Switching to uranium might give us the extra time we need to further better and cleaner renewable energy sources. Plus, some countries like India, China, and Russia are already working towards using the greener and more abundant thorium to power nuclear reactors. If we switch to thorium, we will have even longer than 80 years or fuel available. However, if scientists are able to turn nuclear fusion into a reality, we would theoretically even run out of electricity ever again. Turning nuclear energy into sustainable energy requires the use of breeder reactors and nuclear fusion to sustain as the foreseeable future. So we already done with the advantages of nuclear power plant. So we have here the cons or the disadvantages of what nuclear power plants do, no? So first we have the environmental impact. Second is the expensive to build. Third is risk of nuclear accident. Fourth is radioactive waste. And lastly, we have here the non-renewable energy. So let's go to the first disadvantages, which is the environmental impact. So what is environmental impact? Environmental impact is the nuclear power plants have a greater impact on the environment than just the waste they produce. The mining and enrichment of uranium are not even environmentally friendly. Open pit mining for uranium is safe for miners but leaves behind radioactive particles, causes erosions, and even pollutes nearby sources of water. Underground mining is much better and expose miners to high amount of radiation while producing radioactive waste rock during the extraction of process. So the second disadvantage of nuclear power plant is it is expensive to build. So building its own nuclear power plant relatively expensive to operate. Nuclear power plant doesn't are incredibly expensive to build, and the cost keeps rising. No, from 2002 to 2008, the estimated cost to build the nuclear power plant grows from 2 to 4 billion US dollar to 9 billion US dollar. And power plant often surpass their cost estimating during construction. In addition to the expenses of building the power plant, nuclear power plant must also allocate funds to protect the waste they produce and keep in cooled structure with security procedures in places. All of these costs make nuclear power plant quite expensive. So the third one is the risk of nuclear accidents. Accidents can happen no matter how careful you are. A meltdown at a nuclear power plant can have a catastrophic impact on the surrounding areas, which we know from event like in the Fukushima disaster, in Chernobyl, and their Miles Island in Pennsylvania. No? In the event of nuclear meltdown, harmful radiation can leak which can cause adverse effect on the environment and human health. The 1986 incident in Chernobyl ultimately led to the 1,000 deaths, which estimate ranging from 4,000 to 6,000 deaths as the result of incidents. Nuclear power presents a unique threat to our national security because it is powered by nuclear energy. Terrorists might target nuclear power plants with the intention of creating a disaster, and the uranium used to produce the power can be turned into nuclear weapons if they end up in the wrong hands. For this reason, security surrounding nuclear materials and nuclear power plants is extremely important. The fourth disadvantages of nuclear power plant is what we call the radio waste. So the radio waste from nuclear power energy production is incredibly dangerous. Storage of radioactive waste is major challenge facing nuclear power plants because there's no way to destroy nuclear waste. The current solution is to seal it securely in container and store it deep underground where it can contaminate the environment. As technologies improve, we will hopefully find better ways to store radioactive waste in the future. So lastly, the nuclear energy power is a non-renewable energy source. This is because the fuel in nuclear reactor, uranium, is infinite resources. As we mine uranium, we deplete the amount of available and more will not be produced with a human lifetime. Right now, experts believe that there is about 200 years worth of uranium available, assuming we stay at the same rate of nuclear production, but we have become more reliant on nuclear power in the future. The supply of uranium will deplete faster, which may cause problems in the year ahead. And that's all for the report of Group 6 with a theme of nuclear power plant. Thank you for watching. Bye guys.